these are systems of linear equations notes, and we're going to be basically using all of your graphing skills that you did in the previous unit and a lot earlier this year to help you find a solution to a system of linear equations in this section. So first of all, what is a system? A system of linear equations consists of two or more linear equations with the same variables. Okay, two or more linear equations with the same variables. A solution to a linear system is an ordered pair that is the solution in each equation in the system. And on the graph, it's the intersection point. So we're going to prove that right now with these two problems, the system right here. So we need to graph the equations. So we're going to use slope-intercept form to graph them. So m equals 1, b equals -3 in the first guy. And in the second guy, I'm going to do in a different color. You may want to pause and get some color right now as well. M equals -1/5, b equals 3. All right, so my blue line, I am going to plot. So I start at -3, and I'm going to go up 1 over 1. You definitely need a ruler for this as well. I'm going to continue this on my coordinate plane here because I want to be able to easily see where my intersection point is going to be. In my pink line, I have my y-intercept of 3, and then my slope is down 1, right 5. So down 1, and I'm right there. I don't even need to continue going because I already have my intersection point. So when I draw these two lines with my ruler, okay, you get your arrows because it continues on, you can see the intersection point. That intersection point is a solution to both equations because everything on the line is a solution, remember. So what is that point? What are the coordinates of that point? That point is at what? 5, 2. I'm going to do it in a different color. 5, 2. That's that point right there, 5, 2. So we need to verify that 5, 2 is a solution in each one. And we're going to substitute 5 in for x and 2 in for y. Okay, so the very first equation was in blue, so I'm going to do that check right here. So 5, 2, x, y, right? So 2 is at equals question mark, 5 minus 3. 2 equals, 5 minus 3 is 2, checks. What about in the pink line? Let's check that one. So y is 2, 1/5 times, we don't need their x there, 1/5 times what number? The x, right? So it's 5 plus 3. So 2 equals, that's like 5 over 1. So 1 times 5 is 5, 5 times 1 is 5. So that reduces to a -1 times, plus this 3 over here, which is 2. 2 equals 2, that checks. You physically need to do the checks to make sure that it works. So you don't just go, oh, I'm sure it's good. Because if you made a graphing mistake, then you've got the wrong point. So the solution is 5, 2. So see how important that graphing that we did in the previous unit is. And a lot earlier this year. Okay, so the next one, we're going to graph both of these. So in this one, my m is a -3, or a -3 over 1, and my b is -2. In my other equation, my m is a -3 over 1, and my b is 3. So let's graph the blue line. So we started at -2, and then we go down 3 over 1. The other way would be up 3 and left 1. Up 3 and left 1. So I'm going to graph that line. Get my arrows. Okay. And then we're going to use the pink one. We're going to do the pink one. We're at 0, 3, down 3 over 1, down 3 over 1. I don't see an intersection point. Why don't I see an intersection point? Because the lines are what? I drew it perfectly. The lines are parallel, right? So it says graph the equations. The graphs appear to be parallel lines. You can confirm that the lines are parallel by observing from their equations that they have what slope? What is the slope? It's the same. The same slope has parallel lines. So if the lines are parallel, where are they going to touch? They're never going to touch. The reason why I know they're parallel is because they have the same slope and they have different y-intercepts. So the slope was -3, but they have different y-intercepts. They were 0, -2, and 0, -3. So because the parallel lines don't intersect, what can you say? What do you think is going to happen? The system has no solutions. So it's possible not to get an intersection point like we did on the last one, and this is the case. Okay, example 3, we're going to solve these two equations and find their intersection point. So the first equation is not in slope-intercept form, so you need to subtract 2x to both sides to get it in slope-intercept form. So y equals -2x plus 4. My m is -2, and my b is 4. So I'm going to graph that guy right now. So I go to 0, 4, down 2/1. I'm going to continue it for a little bit there. Go up to back 1 as well to get that other point. And there's my line. Okay, now for blue, it is not the second equation in slope-intercept form either. So I first have to add 6x to both sides, so I get -3y equals 6x minus 12. Divide everything by -3. And I end up with -2x plus 4, because the negative divided by negative is a positive. So my slope is -2, and my y-intercept is 4. Well, that sounds familiar, doesn't it? My y-intercept is 4, down 2/2, down 2/2. What is this? This was the same equation in disguise. It is the exact same equation. So the slope-intercept form of these two equations are identical, so the graphs of the equations are the same line. Okay? So because the graphs have infinitely many points of intersection, they touch everywhere. Infinitely many points of intersection. The system has infinitely many solutions. Infinitely many solutions. Okay? Any point on that line, y equals -2x plus 4, represents a solution. All right, so our next page, you have 2 to do here. You are going to decide if there's one solution, no solutions, or infinitely many solutions. The first one's in slope-intercept form. The second one is not. So you're going to pause the video, work those out on your own, and then come back and check. See how you did on this? So this one, the solution is 3, 0. I checked it over on the side, and it does work. And this one has no solution. They both are parallel lines, and I could see that because they had the same slope of -5, yet they had different y-intercepts. So if you have a question about either of those, go see Mrs. Wyman. All right, in example 4 down here, we're going to talk about a word problem and why we would need a system to help us solve a real-world problem. So we have an ecologist, and they're studying the population of 2 types of fish in a lake. Using the information in the table to predict when the population of the 2 types of fish, you're going to use it to see when they will be the same. So that basically would mean where they intersect, right? So we have fish type A. The current population is 340 of them, and they're going down by 25 a year. Fish type B, the current population is 180, and they're going up 15 a year. So fish population A, we're going to write a linear equation to model that. So we'll say y equals -25x, because the slope, the change, is going down 25 each year, and it's x years. Y was the number of fish, okay? And we started off with 340. The second one, fish type B, y equals, what's the change? 15 per year, going up, and we only had 180. And that one, what you will do is on your graphing calculator, you're going to plug these in, and you're going to find out where they intersect. And you have to zoom way out because look at where my values are here, my y values. And on your graphing calculator, you need to do it, pause the video and do it. What did you get? You should have gotten 4,240. And that would be a reason to have a graphing calculator as opposed to graphing by hand. The graphing calculator saves you. So the number of fish will be the same after 4 years when the population of each fish will be 240 fish of each type. All right, if you have a question about graphing that on your graphing calculator, go see Mrs. Lyman. Otherwise, you are good to go on the assignment here. Okay, you're going to say your M equals B equals for these, and you're going to graph them out, and then you are going to identify the intersection points, and the directions at the top tell you what to do with the letters at the bottom there. And you'll continue on through your packet from there. Nice job on the notes.